Hello, my name is Davis Binger, and let's talk about Taylor series and differentiation. Today we will be looking at problem 5 of the 10.3 and 10.4 handout. We will consider the function f of x equals sine of x squared and the associated Taylor function for f centered at 0. We will differentiate the Taylor series to find a Taylor series for the derivative centered at 0, then identify f prime of x and give an interval of convergence for the differentiated Taylor series. Let us remember the Taylor series for sine of x centered at 0 is given by the sum from k equals 0 to infinity, negative 1 to the k, x to the 2k plus 1 divided by 2k plus 1 factorial. This series converges for all x. Now, by plugging in x squared into this series, we can find the Taylor series for sine of x squared centered at 0. It is just the sum from k equals 0 to infinity, negative 1 to the k, x to the 4k plus 2 divided by 2k plus 1. Furthermore, this series converges for all x. Now we can find the Taylor series for the derivative by differentiating this series term by term. Each term is a monomial. It's a constant times a power of x. Thus we can use the power rule. So the derivative of negative 1 to the k, x to the 4k plus 2 divided by 2k plus 1 factorial is just 4k plus 2 times negative 1 to the k, x to the 4k plus 1. We've reduced the power by 1 divided by 2k plus 1 factorial. Notice that 4k plus 2 is equal to 2k plus 1 times 2. Hence we can cancel out a 2k plus 1 here with a 2k plus 1 here, and we are left with the sum from k equals 0 to infinity, 2 times negative 1 to the k, x to the 4k plus 1 divided by 2k factorial. Now, the derivative of sine of x squared is 2x cosine x squared, and we have the Taylor series for 2x cosine x squared, which is as above. Since the series for sine of x squared converged for all x, this series also converges for all x, and the radius of convergence is infinity. Thank you for watching, and as always, you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.